Okay, everyone, today we are going to talk about representing fractions as decimals, and in particular we're going to be determining if a value is terminating or repeating. So please write down these definitions. A terminating decimal is a decimal that ends or stops. So think back to the movie The Terminator. It stopped. The decimal wants to stop. So, for example, I could have values like 0.4 or 0.38 or 0.375. All of those values are stopping. There's not a pattern to it, and they are not going on forever. However, another type of decimal is a repeating decimal. And that's a decimal with a pattern of a fixed number of digits that repeats forever. So this value would be going on forever, and it's going to be repeating either a certain number or a certain pattern. So for example, for repeating decimals, we could have 0.3 repeating. Do you see this little line that I drew above it? That means that your decimal is repeating. So we would have 0.3, 3, 3, 3, 3, and so on. Another example would be 0.25 repeating. So that decimal would be 0.25, 25, 25, 25, and so on. And sometimes you might see them like this. You might see like 0.423, 423, and then have the dot, dot, dot afterwards. So 423, 423, and then the dot, dot, dot means that the 423 is repeating. So down here it says identify which number below is an example of a terminating decimal and which number is a repeating decimal. Write down the vocabulary term next to each. So, anytime you are given a fraction like you are here, first divide that in your calculator, and remember you always type in your numerator first. So if you take 5 and divide it by 16, you would get this value. It's 0.3125. This decimal stops, therefore it is terminating. The next example, -7 divided by 3, if you put that in your calculator, you would have -2.3333 dot, 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 which means this is repeating. Another way you could have wrote that was -2.3 with the line above it. Now this next value, it says, take a look at this number, 1.01, 001, 0001, and so forth. What do you notice about it? Well, things that you should notice about this are that that decimal is non-terminating and it's non-repeating. Kids will say that there is a pattern to it. However, the pattern is not repeating constantly. It's not the same digits repeating over and over again. There's not a specific pattern of repeating values. So I would classify this as non-terminating and non-repeating. We will get into this specific case right here that we just talked about later on in the week when we talk about rational or irrational numbers. But just so you know, for today's purposes, yes, this is still a value. You can have values that are non-terminating and non-repeating. So down here, we're going to try some examples, and we're going to say if they either terminate or repeat. So, first thing you do, anytime you are given a fraction, first divide it in your calculator. So if I take 2 and divide it by 5 in my calculator, I would get 0.4. This decimal stops, therefore it is terminating. I would like you to try the rest of these B through F on your own. However, for letter E, I want you to cross it off, and I want you to write down 6/18. That's what I want you to try in your calculator for that one. So pause the video, figure out the decimal of B through F, and then write down if it terminates or repeats. And then whenever you are ready to check your work, just press play again and you will be able to see it. So as you can see, letter B and C both terminated because the decimal stopped. Letter D This was that special case that we talked about a little bit above, that the decimal is non-terminating and non-repeating, that we'll get into later on. And letter E and F were both repeating, because in letter E, the decimal, the digit that's repeating was, and I'll write it in red over here, was just a 3. And in F, the digits that were repeating were 1, 5, 3, 8, 4, 6. And that's the digit that just kept on going on and on and on forever. So I hope by now you're able to see the difference between terminating, which stopped, and repeating decimals. If we move on to the next page, we have a little bit more work. So letter G says Jan is hungry and eats 2/3 of a pizza. Convert this fraction to a decimal and determine whether it is terminating or repeating. So if I take 2/3 in my calculator, 2 divided by 3 would give me 0.6666 and so forth. That means it's the same as 0.6 repeating, so this would be a repeating decimal. The next one, Marcy wants to buy 1/4 pound of fudge, so if I convert 1/4 to a decimal in my calculator, I would get 0.25. Since that decimal stops, it is terminating. I want you to ignore that says enrichment, because it really isn't. I want you to try to do A through C right now. Actually, instead, we're going to talk about these. So part A says 0.3. So for each decimal, first you have to find the equivalent fraction. So in this one, since the 3 is in the tenths place, the fraction would be 3/10. And just so you know, this decimal terminates. It stops because it was just 0.3. Part B, 0.333 repeating, the decimal of that, which you guys should probably know, is 1/3. And this decimal is repeating because it was 0.3 with the line above it repeating, because your decimal is going on forever with the same pattern repeating. Part C is one of those special cases we talked about that we haven't really talked about yet, how to find the decimals of those, because this is something called an irrational number that we will get into later. So just know that this one is non-terminating and it's non-repeating. But like I said, we will talk about that later. Now, if you look at part D, it says Natalia has a broken calculator, iPod, iPhone, and iPad. She can't use these devices to help her solve the problem, so now she has to do long division to solve 2 divided by 3. OMG, I know you guys forget how to do long division, and let's try it out. And it says continue the long division process until you can predict whether this decimal is terminating or repeating. Long division really is not that bad. So if I want to do 2 divided by 3, and I did not have a calculator, I'm going to start to set up my problem. Okay, can 3 go into 2? No. So that's when I put my decimal and add my 0. I'm going to put my decimal up there. Can 3 go into 20? Yes, it can. 6 times. So 6 times 3 is 18. If I take 20 minus 18, I would get 2. But as usual, 3 cannot go into 2. So I have to bring down a 0. Can 3 go into 20? Yes, we just talked about it. 6 times. 6 times 3 is 18. If I subtract those, I get 2. And I can keep on doing this process, and no matter what, you're going to see a repetition for this particular example. It's just 0.6 repeating. So 2/3 is a repeating decimal, and you would see that no matter what, I would keep on getting the repetition of 6. I want to look at another one of these. So let's try this one. This time I want you to try to divide 2/7 with a long division. So we're going to go 7 Can 7 go into 2? No. So that's when I put my decimals and I add a 0. 7 can go into 20 2 times. 2 times 7 is 14. And 20 minus 14 gives you 6. 7 cannot go into 6 evenly, so that's why I bring down a 0. 7 can go into 60 8 times. 8 times 7 is 56. If I subtract those, I'll get a 4. 7 cannot go into 4, so I have to bring down another 0. 7 can go into 40 5 times. 7 times 5 is 35. And I'm just going to keep on doing this process. 7 can go into 57 times. So 7 times 7 is 49. I'll get a 1. Bring down my 0. 7 can go into 10 once. If I subtract, I'll get 3. I'm running out of room. If I bring down my 0, 7 can go into 30 4 times. 7 times 4, I'm going to do this up here, is 28. If I subtract, I'll get 2, bring down my 0. 7 can go into 20 2 times. And you are going, and I'm going to stop right here because I'm running out of room, but you are going to start to see the same repetition here that I started with here. So 2 sevenths is a repeating decimal, and the part that repeats would be 0.28574. So we just wanted you to know that long division really is not that bad, and it is manageable. On this page, what I'd like you to do now is try to convert the fraction to a decimal, and then write down if it is terminating or repeating, so you can pause the video, and once you're ready, you can press play and check your work. Okay, if you just press play, you will see all of my decimals, and if you're scrolling along, you would see that every single value on this page was terminating. There was never an answer that was repeating, and they all stopped. And we'll talk about that starting tomorrow, because you're going to see if your denominator is a power of 10, or you can make it into a power of 10, you would then know right off the bat that your decimal would be terminating. So everyone, your questions for homework would be the Schoology quiz and all of the questions on this page. So you have two parts for homework tonight, the Schoology quiz and this page that I'm showing you. And tomorrow in class we will go over this page and start to move on. And if you have questions, as always, ask your teacher. Thanks so much. Enjoy your day.